Practice number 4. So your family's traveling in your car for 100 miles. How long will the trip take if you average 30 miles per hour? So that would be 100 divided by 30. So it would take 3 hours and 3 repeating, so that'd be 3 hours and 20 minutes or so. If you were going 100 miles at averaging 55 miles an hour, 100 miles, the distance over your rate, and that will equal your time. And the same thing with 65. Well, what I'm trying to get at here is we want a function that describes the time it takes to make the trip as a function of your speed. So if we got the function of speed equals the distance over your speed. So 100 over however fast you're going. So it's a function of your speed. So the left side here, that is your time. And on the right side, this is distance over speed. Graphing functions don't care so much about that. Asymptotes. The asymptotes, there's an asymptote at the speed cannot equal 0, so you can't go anywhere if you don't have a speed. So that's one of your asymptotes. And the other asymptote is y cannot be, in this case y is f of s. That cannot be 0 either. So it's like this is the same thing as x equals and y equals. So those are your asymptotes. Moving on, I don't have to worry about D. So looking at our next problem, Michael can rake a lawn and bag the leaves in 5 hours. Emma can rake the same lawn and bag the leaves in 3 hours. You go, Emma. Just kidding. Working together, how long would it take them to rake the lawn and bag the leaves together? If you need help, if you Google rational applications, then click on Khan Academy. The answer is there. Otherwise, obviously, you're already here, so why not do it? So the first thing is, let's write down M for Michael and E for Emma. So Michael can do one lawn. So one lawn in 5 hours. Emma can do one lawn in 3 hours. And where I'm coming up with this is we have the amount of work you can do is equal to the rate of which you can work times the time. And for each one of these, we know that the time is one thing we have. So we have the time. The time is, in Michael's case, it took 5 hours, and in Emma's case, it took 3 hours. So it's the rate at which these guys can work is one lawn per 5 hours and one lawn per 3 hours. We then want to take and we want to see how they're going to work together. So we have Michael, his rate, plus Emma's rate equals their rate together. We're making one lawn. How much time is it going to take? We don't know. This is where we can just solve our problem. So getting like denominators, multiply by 3t on the left, multiply by 5t in the middle, and 15 on the far right. I'm going to continue it up here. 3t plus 5t equals 15. So that's 8t equals 15. Divide by t, you get 15 over 8, which ends up being 1.87, should have known that at the top of my head, 1.875 hours. So they definitely do better working together. Moving on. So reading this, hopefully you read it already. You can go to Khan Academy and look there if you want to see how Khan does it, but otherwise you're here, so let's do it. So Ava and Alex. So Ava and Alex, because they both start with A, we'll have to pick different letters. So Ava will just say V, Alex is going to be X. So Ava, so it's very similar to the top where it's work equals rate times time, because they're doing work and they're giving the hours. We want to figure out the hours, so we want divided by rate. So Ava, we don't know. So one deck, we don't know how long it takes her to do this. So we want an hour here. And Alex, we don't know, again, how long it takes Alex to do this. But we do know that Alex stained it by himself, and it took twice as long as Ava did. So we're going to incorporate this into the formula. So it's Alex is 2 times the rate of Ava. So let me back that up. So I think it'd be easier if we just, probably for you, so the rate of Ava, Alex is going to take twice as long on that. So that rate that Ava did is going to be twice as long for Alex. Sorry, Alex. So we have Ava's rate plus Alex's rate equals them work. So this is adding is working together. One deck, and it took them 8 hours. So the rate. Because this is all one video, I made a mistake. I'm not going to go back and re-erase. I can't go back. Instead of dividing by R here, we should have divided by T. And so these are technically 2 times the time. And so these are T here. And I noticed this because all the labels have to be the same time, 2 times the time, and 8 is time also. So sorry for that. But now hopefully we're good. So looking at T, 2T, and 8, the denominators, we need to figure out what's the least common denominator is 8T. So multiply the first by 8, second by 4, and the last by T. So we have like denominators. So we have 8 plus 4 equals T. So T equals 12. So that's the time. I'll be plug it back in the time here. Ava paints 1 deck in 12 hours. So Ava took her 12 hours to do the deck. Hopefully she got paid pretty well for that. Alex has 24 hours to paint the same deck. It's a lot of work. So there you go. As well, Alex takes twice as long, so you can put 24, 2 times 24. Moving on. Okay, read this one out, and I'll start in just a minute. Okay, so this should be very similar to the last one, except now instead of people, we have hoses. So, hose 1, that hose it takes to fill up the pool is 1 over, and I'm just going to have X. Hose 2 is, and I'm just picking 1 and 2. It doesn't matter. One of the hoses takes 10 minutes faster than the other to fill up. So you could do X minus 12, or you could do X plus 12 on one of them. And so this one here takes 12 minutes longer to fill up than this one. So 1 pond, X minutes. So 1 pond, it takes X minutes to fill up. In this case, that same pond, it takes X plus 12 minutes to fill up. So we have 1 over X plus 1 over X plus 12 equals 12. I should add 10. Friday. 10 more minutes. And together, adding these together, it takes to fill 1 pond up per 12 minutes. So this is our equation here. So this is the rate. These are the rates, by the way. Rates at which they fill up. A lot of these problems are coming from distance times rate times time. You have to figure out what you have and what you don't. We have the distance, or I guess in this case it's work. We have time. So we're finding rate on both of them. So it's the amount of work is fill up 1 pond in how many minutes. Anyways, we got this equation over here. Looking at like denominators, there isn't anything. Nothing alike. There's an x as a factor, x plus 10 and 12. There's nothing in common. So we're going to end up having to multiply everything by everything to get to the same denominator. So this has just an x, so I have to multiply by x plus 10 and 12. So 12 times x plus 10. Here we have an x plus 10, but I need to multiply that by x and 12. So I have an x, 12, and x plus 10. The last one, I already have a 12, but I don't have an x, and I don't have an x plus 10. So you do that to the numerator and denominator. I'm not doing it to the denominator because we end up just canceling them out anyways. So the first one here, I'm going to distribute 12x and 120, and it's times 1, so it's just 12x plus 120 equals 1 times x, or 12x is, this is an equals, it's plus. Tell you it's a Friday. 1 times x is x, and then distribute it in, you get x squared plus 10x. Now you see it's quadratic, so move all the terms to the one side, so subtract 12x over here, add these two together, 120 and 12. You get 0 equals x squared minus 2x minus 132. Alright, so I made a mistake again. Sorry. Yeah, I forgot the x here. So that's 24x. And when you subtract 24x from 10x, you get negative 14x. And then this should have been minus 120. So you can use the quadratic formula, or you could factor this. Since the a term is 1, you can quick shortcut. What two numbers multiply to negative 120? That add up to negative 14. And that's x minus 20, x plus 6. And set each factor equal to 0. And solve them. So add 20, so x equals 20, and x equals negative 6. Well, we're talking about a real world problem here. Time, x is time. So time only is positive. So x equals 20 minutes is the only solution. Can't have a negative time, so that can't be a solution. So 20 minutes. All right. Hopefully this helps you out. I will do more in class. Moving on for practice 8. Thanks.